Our universe isn't just big, it's beyond comprehension in ways that twist the mind. Picture every beach on Earth, those golden shores stretching from the tropics to the Arctic edges. Now, count every tiny grain of sand on them all, billions upon billions, right? Well, hold on to that number because the stars in our observable universe outnumber those grains. Yes, more stars than sand on every beach combined. It's a fact that astronomers have pieced together through years of patient observation, using telescopes that peer back through time itself. But here's where the mystery deepens. Despite all those stars, the universe feels eerily empty. If you could shrink each star down to the size of a single grain of sand, the average distance between them wouldn't be a few inches or even a few feet. It would be about 5 miles. That's like standing on one mountaintop and looking across to another, with nothing but silence in between. This sparsity isn't just a quirky detail, it's a profound truth that shapes everything about our place in the cosmos. Think about it. We've sent probes out there, like the Parker Solar Probe, launched by space agencies to skim the sun's atmosphere. It's the fastest thing humanity has ever built, hurtling through space at speeds that would make your head spin. Yet, even at that blistering pace, it would take that probe around 7,000 years to reach the nearest star beyond our Sunday. 7,000 years, generations upon generations, empires rising and falling, all while one little machine drifts through the dark. And that's just to the closest neighbor. The nearest galaxy? That would multiply the journey by hundreds of thousands of times, turning it into an odyssey that spans the entire history of human civilization and beyond. But why does this matter to you, right here and now? Because it reveals something intimate about us as a species. We're trapped, in a way, in this invisible cage of physics rules that govern speed, distance, and time, keeping us tethered to our tiny blue dot. It's like being locked in a room with windows showing vistas you can never touch. Yet, throughout history, we've refused to accept those bars. Remember the tales of ancient sailors, like those who followed Christopher Columbus across uncharted oceans? They stared at the horizon, convinced there was more beyond the waves that swallowed ships whole. Myths of sea monsters and falling off the edge didn't stop them. Instead, they fueled the fire. Today, we face a similar frontier, but on a scale that dwarfs those old maps. The universe isn't hiding dragons, it's concealing wonders like black holes that bend light, nebulae, birthing stars, and perhaps even other worlds teeming with life we can only imagine. This sense of being confined yet compelled to escape is what drives our greatest stories. What if the universe is designed this way on purpose? A cosmic puzzle, testing our ingenuity. Some thinkers whisper about hidden dimensions or shortcuts through space-time, ideas born from equations scrawled on chalkboards in quiet labs. Others ponder if we're alone in this vastness, or if echoes of distant civilizations are out there, waiting for a signal we'll never hear because the gaps are just too wide. It's thrilling, isn't it? That blend of awe and frustration, knowing we're clever enough to glimpse the puzzle but not yet to solve it fully. As we dive deeper into this journey together, I can't help but think about how sharing these wonders connects us all. If this tale of cosmic vastness is sparking something in you, maybe a spark of curiosity or a quiet thrill, why not hit that like button to let others discover it too? And if you're subscribed, you're already part of this adventure crew. If not, join us for more explorations like this. Oh, and drop a comment below with where you're listening from and what time it is there, like sending a little postcard from your corner of the world. It makes these stories feel even more alive, knowing we're all scattered under the same stars, pondering the same mysteries. Now, let's pull back from those grand vistas and ground ourselves in the here and now. Our solar system, this cozy neighborhood we call home, is just a speck in the grand scheme. But even within it, the distances humble us. From Earth to the Moon, a mere hop that took astronauts a few days back in the 1960s, to Mars, months of travel with our current rockets. But step outside that beyond Pluto, into the interstellar void, and suddenly, years turn into centuries. It's not just empty space, it's laced with invisible forces, like the cosmic microwave background, a faint glow left over from the universe's fiery birth nearly 14 billion years ago. Scientists measure it with instruments that detect whispers from the dawn of time, reminding us that the universe has a history, a story unfolding long before we arrived. Yet, amid this emptiness, There's beauty in the isolation. Imagine drifting alone in that space, watching stars wink like distant fireflies. Would it feel lonely or liberating? Some astronauts who've orbited Earth describe a profound shift, a sense of unity with the cosmos, seeing our planet as a fragile marble suspended in nothingness. It's called the overview effect, a real psychological phenomenon that changes how you see everything. Perhaps that's the universe's gift, forcing us to confront our smallness, which in turn ignites our drive to reach further. But what if we could break free? What if imagination bridged the gaps that physics won't allow? That's the heart of our tale tonight, a hypothetical voyage aboard a ship unlike any we've built. Not bound by fuel limits or fragile human frames, but powered by the boundless what-if of the mind. Before we launch into that, though, let's linger on the real barriers. Light itself, the fastest traveler we know, takes 4 years to reach that nearest star, Alpha Centauri. 4 years for a beam of light, no stops, no slowdowns. For us, with our clunky machines, it's an eternity. Probes like Voyager, launched in the 1970s, are still crawling out there, barely scratching the edge of our solar system's bubble after decades. This leads to wild speculations. Could there be wormholes, tunnels through space that fold distances like paper? Theories from physicists like those inspired by Albert Einstein suggest maybe in the realms of general relativity. Or perhaps advanced civilizations have mastered warp drives, bending space around them. These aren't just sci-fi tropes. They're grounded in math that real scientists debate over coffee in university halls. It's this mixed solid facts intertwined with tantalizing maybes that makes the universe so addictive. One moment, you're marveling at confirmed discoveries, like the thousands of exoplanets found by telescopes scanning the skies. The next, you're wondering if one of those worlds holds beings gazing back at us. As we build this picture, remember the human element. Explorers of old didn't just sail for land. They sought stories, riches, and understanding. Today, space agencies pour resources into missions not for conquest, but for knowledge. The James Webb Space Telescope, peering into the infrared depths, has unveiled galaxies from the universe's infancy, showing us how it all began. Each image is a time capsule, light that left its source billions of years ago, finally reaching our eyes. It's poetic, almost the past whispering to the present. Yet, for all our progress, the cage remains. Our fastest ships, mere snails in the cosmic race. The Parker probe, zipping at over 400,000 miles per hour near the Sun, slows to a crawl in the interstellar chill. It underscores a truth. We're engineered for this planet, not the stars. Our bodies falter in zero gravity. Our minds crave connection. But that's where the dream steps in. What if we crafted a vessel that defies these limits? One that accelerates steadily, mimicking Earth's pull, carrying us across the voids without the agony of time. Before we unveil that ship, let's savor the tension. The universe challenges us not with malice but with invitation. It's vast to inspire, empty to intrigue. In the quiet of night, as you listen, feel that pull, the same one that drew stargazers millennia ago. From ancient astronomers mapping constellations to modern ones charting black holes, the quest endures. And speaking of enduring connections, if this cosmic whisper is resonating with you under the stars or in a cozy room, share your spot in the universe below. Like and subscribe to keep these journeys coming, and comment with your location and the hour. It's like collecting postcards from fellow travelers in this grand adventure. Now, as we edge closer to launch, consider the philosophical twist. Is the universe's scale a barrier or a beacon? Perhaps it's both, urging us to evolve. In the coming moments, we'll board our imaginary craft. But first, let's acknowledge the real pioneers, those who've pushed boundaries, from the Apollo crews to the rovers on Mars. Their stories remind us that every great leap starts with a single, bold step into the unknown. This opening glimpse sets the stage for wonders ahead. The universe isn't just out there, it's a mirror to our own boundless potential. So, settle in, let the mystery unfold, and prepare for takeoff. If these cosmic thoughts are drawing you in, consider subscribing to join more adventures like this. Hit that bell for notifications so you never miss a launch into the unknown. Now, as the engines hum to life in your mind's eye, let's step aboard this extraordinary vessel, a craft born not from steel and circuits alone, but from the wild edges of human ingenuity, where science meets the impossible. This isn't your everyday rocket, sputtering fuel in short bursts like the ones we've launched toward the Moon or Mars. No, this ship is a marvel of steady, relentless motion, designed to propel us across the stars without the brutal jolts or endless waiting that plague our current explorations. At its core is a propulsion system that accelerates at a gentle yet unyielding pace, roughly 10 meters per second squared, about the same pull you feel standing on solid ground back home. It's this constant push that mimics Earth's gravity, turning what could be a disorienting float into a familiar stride, as if the cosmos itself were bending to our comfort. Picture the moment you cross the threshold. The airlock seals with a soft hiss, and suddenly, the weight of the world, or rather, the lack of it, doesn't vanish as it does for astronauts on the International Space Station. Those real-life spacefarers, orbiting our planet right now, endure months of weightlessness that wreaks havoc on their bodies and minds. Muscles atrophy, bones weaken, and fluids shift in ways that swell faces and strain hearts. But on our ship, that constant acceleration creates an artificial gravity, pressing you downward toward the floor with the same reassuring force you've known all your life. It's a clever trick, one that scientists have dreamed about for decades, inspired by concepts like rotating habitats that spin to simulate pull. In fact, as of this year, 2025, researchers at agencies like the National Aeronautics and Space Administration are funding studies into just such ideas through programs like the NASA Innovative Advanced Concepts Initiative. They're exploring ways to build spinning modules for future stations where centrifugal force could keep crews healthy during long hauls to Mars or beyond. Our imaginary ship takes that a step further, weaving it into every fiber of its design, so you can walk, eat, and sleep as if you were strolling through a quiet park on a summer evening. Yet, this comfort comes with layers of wonder that unfold as you settle in. The acceleration isn't a burst of fire like in old launch videos. It's a smooth ramp-up, building speed second by second. In the first minute alone, you're already moving faster than a commercial jet. And by the end of the hour, velocities climb into realms that make earthly travel seem quaint. But here's the intriguing part. Because it's steady at that 1G level, your body doesn't rebel. No queasy stomachs from sudden thrusts, no blackouts from overwhelming forces. Instead, it's like being in a car that never stops speeding up, yet the ride feels as calm as a train gliding through countryside. This draws from real physics we've tested on Earth, centrifuges in labs where volunteers spin for hours to mimic these effects, proving that sustained gravity could prevent the bone loss and muscle waste that afflict station crews. Imagine the relief. Astronauts returning from 6-month stints on the station often need weeks to readjust, their legs wobbly like newborns. On our ship, you'd step off after years feeling as spry as the day you left, ready to explore whatever alien shores await. Of course, the ship's defenses against the universe's harsher side add another veil of mystery. Space isn't just empty, it's a gauntlet of radiation, cosmic rays zipping through like invisible bullets, capable of scrambling DNA and sparking cancers over time. Real missions shield with layers of polyethylene or water walls, but our vessel goes beyond, incorporating hypothetical fields that deflect particles as effortlessly as an umbrella sheds rain. Drawing from cutting-edge ideas in 2025, like those from private companies advancing electromagnetic shields or metamaterials that bend radiation away, this tech ensures you're cocooned in safety. And what about collisions? Tiny micrometeorites, debris from old satellites. These are real threats that have pitted windows on the station and forced emergency maneuvers. Our ship, in its imagined perfection, boasts self-healing hulls, perhaps inspired by the self-repairing polymers being developed in labs today, where materials knit themselves back together like living skin. It's this blend of protection that turns the void from a predator into a pathway, inviting questions. What if we could truly tame the dangers that have held us back? As you explore the interior, the everyday details spark even more curiosity. The living quarters aren't sterile pods but warm, adaptable spaces, rooms that shift with holographic displays, simulating sunrises or starry nights to combat the psychological toll of isolation. We know from station veterans that confinement breeds its own shadows, disrupted sleep from the 16 sunrises and sunsets zipping by each day, anxiety bubbling up in the quiet hours. even subtle cognitive slips like slower reaction times or foggy memories. Studies from the National Aeronautics and Space Administration highlight how these effects compound, with some crew members reporting heightened stress or emotional swings after months aloft. Our ship counters this with rhythms tuned to human needs, artificial days that mimic Earth's 24-hour cycle, complete with soft lighting that eases you into rest. Imagine drifting off not to the hum of machines alone, but to gentle simulations of ocean waves or forest whispers, drawn from biofeedback tech that's already helping ground-based explorers manage isolation in Antarctic outposts. But let's delve deeper into that human side, because the ship's true genius lies in how it nurtures the mind amid the stars. Tension might creep in at first, a flutter in your chest as the familiar blue marble of home shrinks to a pinpoint. It's a feeling echoed by real astronauts, who describe the initial awe mixed with a pang of separation, like leaving a loved one for an uncertain voyage. Yet, as days blend into weeks, the ship's design fosters resilience. Communal areas encourage shared meals, not just for nutrition but for connection tables where laughter echoes, games unfold, perhaps even virtual links to Earth that, though delayed by distance, keep bonds alive. This draws from psychological research on long-duration missions, where experts emphasize routines and rituals to ward off depression. In 2025, programs like the Human Research Program are testing virtual reality therapies on the station, allowing crew to walk through familiar parks or chat with avatars of family. Our vessel amplifies this, integrating adaptive AI companions that monitor moods subtly, offering conversations or meditations tailored to your needs, almost like a wise friend who's always there, whispering encouragement in the dark. This raises intriguing ethical threads woven into the fabric of such a journey. Pursuing this technology, endless acceleration, boundless energy, promises liberation, but at what cost? Real debates in 2025 swirl around space exploration's footprint. The growing cloud of orbital debris that threatens satellites and future missions, or the moral weight of diverting resources from Earth's pressing woes like climate shifts or inequality. If we build ships that guzzle hypothetical infinite fuel, might we exacerbate environmental strains back home, mining rare materials or launching more rockets that scar the atmosphere? Ethicists argue, as in recent studies on interstellar ethics, that extending our reach demands stewardship rules to prevent turning the cosmos into another polluted frontier. There's the human angle too. Who gets to board? In a world where space travel is still elite, does this dream widen divides, or could it unite us in shared aspiration? These questions linger like stars in the night, prompting us to wonder if the ship's perfection mirrors our own potential flaws, urging caution even in fantasy. Shifting gears to the thrill of motion, feel the subtle build as acceleration compounds. Unlike the bone-rattling launches of today, where astronauts endure Gs that pin them to seats, our ride is a gentle crescendo. By the end of the first day, speeds eclipse those of any probe we've sent. Yet inside, it's business as usual, brewing coffee that doesn't float away, reading a book without pages drifting. This stability opens doors to productivity. Labs aboard, where you might conduct experiments on cosmic phenomena, or observatories peering ahead with telescopes that dwarf the James Webb, capturing glimpses of distant worlds in real time. Inspired by 2025 trends in artificial intelligence and machine learning, the ship could even learn from its travels, adjusting courses to dodge hazards or optimizing life support with predictive algorithms, much like how autonomous systems are now guiding rovers on Mars. Yet, amid this seamlessness, a quiet intrigue builds in the solitude. Days stretch, and the view outside shifts from familiar constellations to unfamiliar streaks as velocity climbs. Real station dwellers speak of the overview effect, that profound shift where borders fade and humanity feels interconnected. On our ship, this might intensify, fostering reflections on existence, why we're driven to roam, what secrets the stars hold. Perhaps you journal these thoughts, or share them in group sessions, turning isolation into introspection. Psychological reports from missions note how such environments can heighten creativity, with astronauts composing music or sketching visions that capture the sublime. Our vessel encourages this, with creative spaces equipped for art or science, blurring lines between work and wonder. Delving into the energy source adds another layer of fascination. In our tale, it's boundless, a hypothetical reactor, drawing from vacuum energy or zero-point fields, concepts physicists toy with in labs today. But ground this in reality. As of 2025, fusion breakthroughs promise cleaner power for deep space, with prototypes testing ways to harness stars' own fire. Ethical whispers emerge here too, harnessing such might. Could we risk unintended ripples, like altering local space-time or leaving trails that disrupt ecosystems we don't yet understand? Recent papers on space ethics highlight the need for frameworks, ensuring our quests don't harm potential life out there, or even the delicate balance of our solar system. As routines settle, the ship's adaptability shines. Modules reconfigure for exercise treadmills that adjust to your gait, ensuring fitness without the microgravity woes that plague station crews who battle fluid shifts causing vision blurs or headaches. Nutrition evolves too, hydroponic gardens blooming with fresh greens, countering the monotony of packaged meals that real astronauts endure. Imagine biting into a tomato grown under simulated suns, its tang a reminder of home amid the alien expanse. This self-sufficiency, echoed in 2025's commercial space stations like Starlab, hints at sustainable futures where voyages aren't one-way tickets, but ongoing sagas. Yet, the psychological undercurrents keep the narrative alive with tension. Isolation's grip can tighten, manifesting as vivid dreams or heightened senses, sounds of the ship becoming symphonies, stars outside whispering untold stories. From station logs, we learn of anxiety spikes, with up to 85% of some groups showing signs, often from disrupted circadian rhythms. Our ship mitigates with biolights syncing to your biology, but the human spirit's resilience becomes the true engine. Bonds form deeper, conversations turning philosophical. What if we encounter signals from afar? Ethical dilemmas arise. Do we respond, risking unknown consequences as debated in interstellar contact protocols? Pushing further, the ship's integration with human augmentation adds intrigue. Perhaps neural interfaces, building on 2025's brain-computer links, allow seamless control thinking, the command to adjust views or simulate companions. This blurs self and machine, sparking questions. Does it enhance or erode our essence? Real ethicists warn of dependency, yet the potential for enriched experiences, virtual explorations of hypothetical worlds fuels endless curiosity. In this cocoon of innovation, the voyage transforms from mere travel to transformation. The ship's whispers become your own, urging onward with promises of revelation. As velocities mount, the cosmos unfolds not as foe, but as canvas, where humanity's bold strokes paint futures unimagined. With the subtle thrum of acceleration weaving through every corner of the ship, the first hours unfold like a secret unfolding in slow motion, each tick of the clock pulling you deeper into the embrace of the void. You're not just leaving Earth behind, you're slipping through the familiar veil of our solar neighborhood, where planets and moons that once seemed distant now rush by in a blur of achievement. Barely 2.5 hours in, and there it is, the moon, that silvery sentinel that's watched over humanity for eons, sliding past your viewport like a ghost in the night. It's a moment that hits differently when you're the one racing toward it at speeds that make historical voyages feel like leisurely strolls. Back in the 1960s, the Apollo 11 crew took 3 full days to bridge that same gap, their journey a tense ballet of orbits and burns that captivated the world. Now, under this constant push, you're eclipsing their pace effortlessly, the ship's steady build turning what was once an epic odyssey into a mere prelude. As the lunar surface recedes, craters and Maria fading into a pale disk against the stars, a quiet thrill settles in. What secrets might still linger there, untouched since those boot prints from over half a century ago? Recent missions have hinted at water ice in shadowed craters, potential fuel for future outposts. But from here, it's all speculation, a tantalizing whisper of what could be if we dared to linger. Instead, you press on, the ship's instruments humming with data on radiation levels and micrometeorite counts, reminders that even this close to home, space is no forgiving friend. The acceleration keeps you grounded, literally, allowing you to pace the corridors, pondering the shift. Your thoughts drift to the Apollo astronauts Armstrong, Aldrin, Collins, who endured the raw edge of uncertainty, their craft a tin can hurtling through the unknown. Their 3-day trek included moments of sheer vulnerability, like the docking maneuvers that could have spelled disaster. Here, the smoothness of your ride invites a different kind of introspection, Not fear, but a growing curiosity about how far this engineered grace can carry you. By the time the first day stretches toward its end, the ship has accumulated a velocity that transforms the solar system into a living map unfurling before you. Mars looms ahead, that rusty enigma that's beckoned dreamers since telescopes first pierced the night. In just 1.5 days, you're gliding past its thin atmosphere, closer than any human has come in real time without the months-long waits of conventional flights. The red planet's canyons and polar caps gleam in the sunlight, a canvas of ancient rivers and volcanic scars that tell tales of a wetter past. Probes like those from the National Aeronautics and Space Administration have mapped its surface in exquisite detail, revealing Olympus Mons, the tallest volcano in the solar system, towering over 20 kilometers high. But from this vantage, speeding by at ever-increasing clips, it's the what-ifs that captivate. Could microbial life still hide in subsurface aquifers? Recent findings suggest methane plumes that wax and wane, hinting at geological or perhaps biological activity, stirring debates in scientific circles. You can't help but imagine pausing here, descending to walk those dunes, but the journey's rhythm pulls you onward, leaving Mars as a milestone rather than a destination. As the hours accumulate, the ship's communal spaces buzz, with a mix of excitement and reflection. Shared meals become forums for musing. Someone recounts family stories from back home, their voices carrying a note of wistful distance, even though signals still flow relatively swiftly at this range. A quick message to loved ones takes mere seconds to traverse, but already you sense the creeping delay that will soon stretch conversations into monologues. It's in these quiet interludes that the human element shines through, turning the technical marvel into a vessel of emotions. One crewmate might sketch the receding planets, capturing the ethereal glow of Mars's atmosphere, while another pores over telemetry, noting how the ship's speed now rivals the fastest probes we've launched. The Parker Solar Probe, for instance, has clocked in at over 430,000 miles per hour during its daring sun-skimming passes, a record setter that's pushed the boundaries of engineering. Yet, even that velocity pales as your craft builds momentum, the constant G turning incremental gains into exponential leaps. Pushing beyond Mars, the journey delves into the quieter realms of the outer planets, where gas giants reign in majestic isolation. Jupiter's swirling storms might flicker in the distance, its great red spot, a vortex larger than Earth itself, but at this pace, it's a fleeting spectacle. The ship's logs note the increasing chill as sunlight dims, yet the internal warmth holds steady, a cocoon against the encroaching cold. Curiosity builds about the asteroid belt you've threaded through earlier, that scattered ring of rocky remnants from the solar system's birth. Home to Ceres, the dwarf planet with its salty subsurface oceans that intrigue astrobiologists. Did you know that some asteroids harbor water ice, potential resources for future miners? It's these hidden treasures that make the passage feel like skimming the surface of a vast, untold archive, each body a chapter in the 4.5 billion year saga of our cosmic backyard. As days blend into the second week, the inner solar system feels like a distant memory, and the outer reaches beckon with their own enigmas. Saturn's rings shimmer like a cosmic halo, composed of countless icy particles dancing in gravitational harmony. Cassini probe images from decades ago revealed geysers on Enceladus, spewing water plumes that suggest a subsurface ocean teeming with possibilities for life. From your speeding perch, it's a glimpse that sparks wonder. What organic molecules might lurk in those depths, waiting for a probe to confirm? The ship's acceleration ensures you're not lingering, but the data streams in magnetic field readings, particle counts, painting a picture of a dynamic system where moons like Titan, with its thick atmosphere and methane lakes, mimic Earth's early conditions. It's here that the scale starts to sink in. These worlds, once the frontier of our robotic explorers, now serve as waypoints in a grander exodus. Venturing further, the journey brushes the Kuiper Belt, that donut-shaped expanse of icy relics stretching from Neptune's orbit at 30 astronomical units out to about 50. This frozen frontier, named after astronomer Gerard Kuiper, harbours dwarf planets like Pluto, with its heart-shaped plains and nitrogen ices, and Arakoth, a contact binary shaped like a snowman, visited by the New Horizons probe in 2019. Billions of cometary nuclei lurk here, remnants from the solar system's formation, occasionally nudged inward to grace our skies as brilliant tales. As the ship slices through, you ponder the belt's role as a time capsule, objects preserved in deep freeze, offering clues to the building blocks of planets. What volatiles might they hold? Keys to understanding how water arrived on Earth. The density is sparse, collisions rare, but the ship's sensors remain vigilant, mapping these ghosts of creation. By the third week, the true edge approaches. The heliopause, where the sun's influence wanes and interstellar space begins. Voyager probes cross this boundary after decades, but here, in mere weeks, you're surging past at speeds exceeding 65 million kilometers per hour, about 6% of light's velocity. The Oort cloud envelops you next, a vast spherical shell extending perhaps 50,000 astronomical units, a bubble of trillions of icy bodies that's the source of long-period comets like Hale-Bopp. Theorized by Jan Oort in the 1950s, this cloud marks the solar system's outermost rampart, where gravitational tugs from passing stars can dislodge objects into centuries-long orbits. From within, it's an invisible realm, no dense fog but a sparse scattering, yet crossing it feels profound, a farewell to the sun's protective bubble. Emotions swirl as home shrinks to a faint star, elation at milestones marked with toasts and shared stories, a pang for the world left behind. Communications lag now, messages taking hours, turning farewells into echoes. Yet, this detachment breeds a fresh perspective, like shedding an old skin. The crew celebrates with improvised rituals, a holographic replay of Earth's sunsets, debates on what lies beyond. Speed accumulates, the ship's path an arrow into the dark, fueling anticipation for the interstellar leap. What anomalies might the instruments catch? Cosmic rays from distant supernovae, or hints of dark matter? Each mock carries a seed of discovery, blending the known with the elusive. As the system recedes, reflections deepen on humanity's tentative steps. Apollo's lunar jaunt, a 3-day triumph of ingenuity, contrasts sharply with this seamless glide, highlighting how far dreams have evolved. Probes like New Horizons zip to Pluto in 9 years, but your pace dwarfs that, inviting musings on acceleration's magic, how it compounds, turning modest starts into stellar sprints. The Oort cloud's fringes blur past, cometary origins, whispering of the universe's volatile youth, where collisions forged worlds. Nearing the 3-week mark, the heliosphere's boundary crosses like a threshold into wilderness. Interstellar winds buffet gently, plasma densities shift, marking the handover from solar dominion to galactic expanse. Voyager 1, still signaling after 48 years, crossed here at a crawl. Your ship barrels through, velocity now, a testament to unrelenting push. The view outside? Stars steady, no longer wheeling with orbital dance, a fixed tapestry inviting endless gaze. In these moments, curiosity peaks. What microbial hitchhikers might ride the solar wind out here? Or how do magnetic fields twist in this transition zone? Data pours in, fueling onboard analyses that echo real mission science halls. The journey's rhythm meals, rests, observations builds a new normal, where each day peels back layers of the familiar, revealing the cosmos's quiet grandeur. As the ship's velocity creeps ever higher, a peculiar whisper begins to echo through the corridors, not from the engines or the hum of life support, but from the very fabric of reality bending under the strain of motion. You've left the solar system's embrace behind, and now, with speeds mounting toward fractions of light itself, the rules of the everyday world start to warp in ways that tease the edges of understanding. It's here, in this accelerating cocoon, that the principles laid out by a quiet thinker over a century ago come alive, not as dry equations on a screen, but as living puzzles that reshape your perception of time, space, and possibility. Albert Einstein's special theory of relativity, born in 1905 from thought experiments in a Swiss patent office, isn't just abstract philosophy. It's the invisible hand guiding your journey, turning what seems straightforward into a labyrinth of surprises. Imagine, for starters, chasing a beam of light across the deck. In your quarters, you flick on a lamp, and the glow spreads out at 300,000 kilometers per second, the cosmic speed limit, unchanging no matter how fast you're hurtling through the void. That's the first cornerstone, Light's velocity is constant, a fixed point in a universe where everything else shifts. Back on Earth, this might sound like trivia, but out here, it unravels intuitions built from slower lives. If you're jogging down a hallway at, say, 10 kilometers per hour and toss a ball forward at the same speed, a stationary observer would clock it at 20 kilometers per hour. Simple addition, right? But swap the ball for light, and the math crumbles. No matter your sprint, the beam races away at its eternal pace, indifferent to your efforts. This invariance, confirmed in experiments like the Michelson-Morley setup of the 1880s, forced Einstein to rethink the basics. Time and space aren't rigid backdrops. They're elastic, stretching and contracting to keep light's speed sacred. This leads straight into the heart of the matter, the Lorentz factor, a mathematical guardian that emerges when velocities flirt with the sublime. Named after Hendrik Lorentz, who glimpsed its form in the late 1800s, it's denoted by gamma, a simple yet profound expression, 1 divided by the square root of 1 minus velocity squared over the speed of light squared. At everyday paces, gamma hovers near 1, unnoticed. But crank up the speed, and it swells, inflating the oddities. On your ship, as acceleration piles on, gamma starts to climb, signaling that time itself is dilating. Clocks tick slower for you compared to those back on Earth, not because of mechanical faults, but because motion warps the flow of moments. It's a dilation that's been measured in the real world. Take muons, those subatomic particles born from cosmic rays slamming into the atmosphere. They should decay in microseconds, too fleeting to reach the ground, yet detectors catch floods of them. Why? Racing at near light speeds, their internal clocks slow, stretching their lifespans from our perspective. Experiments at particle accelerators, like those at the European Organization for Nuclear Research, replicate this daily, smashing protons at fractions of light speed and watching time bend to Einstein's will. But let's make this personal, as if you're the one puzzling it out mid-voyage. Suppose you sync a watch with a friend on Earth before launch. As your ship builds to 87% of light speed a milestone, you'll hit in about 15 months, gamma doubles to 2. From Earth's view, your watch lags. What feels like a minute to you stretches to 2 for them. It's the twin paradox in action. If you zipped off and returned, you'd age less than your sibling left behind. Einstein illustrated this with thought experiments, like trains and lightning strikes, showing how simultaneity fractures depending on your frame of reference. No absolute now exists, it's all relative. And here's where curiosity spikes. What does this mean for your crew? Birthdays pass slower, meals linger in subjective time, while back home, seasons whirl by faster. It's not magic, it's verified. In 1971, atomic clocks flown on jets around the world ran slow by nanoseconds, aligning with predictions. Even global positioning systems rely on this. Satellites orbiting at high speeds experience time dilation, their clocks ticking slower by about 7 microseconds per day due to velocity, offset by general relativity's gravitational effects making them run faster. Without corrections, your phone's navigation would drift kilometers off course daily. Delve deeper, and the theory unveils more enigmas, like length contraction. As gamma grows, objects in motion appear squished along their direction of travel from an outside observer's eyes. Your ship, sleek and elongated, would look stubby to Earth-based telescopes, compressed like an accordion under invisible pressure. This isn't illusion, it's measurable reality, rooted in the same math that safeguards light's constancy. Picture railroad tracks. If you're on a relativistic train, the distance between sleepers shortens, harmonizing with time stretched to keep speeds consistent. Experiments with particle beams confirm it. Electrons at near light speeds behave as if foreshortened, their interactions altered. On board, you feel none of this. The ship remains unchanged in your frame. It's this asymmetry that fuels the Tomo relativity demands we question whose reality reigns supreme. Yours, accelerating through the stars, or the stationary world's? Now, weave in the journey's pulse. As months tick by, 15, to be precise, you celebrate crossing 1 light year. A distance light itself traverses in a year. But here's the twist. While Earth clocks mark 15 months, your ship's chronometers show less, thanks to dilation. Gamma at 2 means your perceived time compresses, making the haul feel shorter. It's a boon for long treks, yet it isolates you further. Messages from home arrive stretched, voices echoing across growing chasms. What stories unfold there while your days lag? Societies evolve, technologies leap, perhaps fusion drives mature, or quantum networks span the globe. This disconnection breeds introspection. Relativity isn't just physics. It's a mirror to human fragility, reminding us that connection, like time, is frame-dependent. Push the envelope, and the impossibilities mount. Approaching light speed, gamma skyrockets toward infinity, demanding infinite energy to nudge further a barrier no clever engineering breaches. Einstein's edict holds. Nothing with mass outruns light, proven in colliders where particles asymptote but never surpass. Your ship, in this hypothetical, skirts the edge, velocity observed from Earth capping at light's pace while you feel endless acceleration. It's a perceptual schism. You surge past light subjectively, but observers see you asymptote, your acceleration dwindling as gamma balloons. Visualize it through a cultural lens. Films like Back to the Future toy with time travel via speed, but relativity grounds the fantasy, showing how 88 miles per hour pales against the real threshold. The DeLorean hits 1.21 gigawatts for a flux, yet true dilation requires relativistic realms, where cause and effect tangle in causal loops. This invites wild speculations. What if wormholes or Alcubierre drives hypothetical bubbles warping space sidestep the limit? Theorists like Miguel Alcubierre proposed such in 1994, envisioning metrics where space contracts ahead and expands behind, effectively faster than light without local violation. But exotic matter with negative energy remains elusive, glimpsed perhaps in quantum vacuums but unharnessed. Your journey teases these frontiers, acceleration, mimicking warp effects in subtle ways, fueling onboard debates. Could dark energy, that mysterious accelerator of cosmic expansion, power such feats? Observations from telescopes like Hubble and James Webb, peering back to the universe's dawn, hint at its dominance, comprising 68% of everything. Yet, relativity's grip tightens on the human scale. As gamma climbs, radiation blue shifts cosmic microwaves. Relics of the Big Bang at 2.7 Kelvin intensify into visible glows, bathing the ship in ethereal light. It's a visual cue to the theory's reach, transforming background hum into foreground spectacle. Crew experiments mimic this. Sinking lasers across the vessel reveals no speed discrepancies, affirming constancy. But the emotional undercurrents run deep. Dilation means farewells stretch eternal. A year's voyage for you might span generations planetside. It's the stuff of sci-fi heartache, like in Interstellar's Waterworld scene where hours equal years, but rooted in math we've tested. Circle back to practical echoes. Particle physics labs routinely harness relativity. At the Large Hadron Collider, protons whirl at 99.999999% light speed, gamma soaring to 7,000, enabling Higgs boson discoveries in 2012. These collisions recreate Big Bang conditions, unveiling quarks and gluons in fleeting glory, all thanks to dilation extending particle lives. Your ship's path parallels this motion as a time machine, compressing eons into lifetimes. Probe further, and paradoxes emerge to tantalize. The ladder paradox. A relativistic ladder fits into a shorter barn when sped, but from the ladder's view, the barn shrinks. Resolution? Relativity of simultaneity doors close at different nows. It underscores the theory's elegance, dissolving contradictions through frame shifts. On board, you might simulate with holograms, watching scenarios unfold, curiosity peaking at each twist. As velocity nears the brink, 95% light in under 2 years, gamma hits 10, time dilating profoundly. Earth's observers see your motion sluggish, communications redshifted into lower pitches. It's isolating, yet empowering, granting you temporal leverage over vast distances. But energy demands escalate. Sustaining acceleration devours hypothetical reserves, mirroring relativity's infinite barrier. This framework reshapes the cosmos. Black holes, where gravity mimics extreme motion, or neutron stars spinning relativistically, dragging spacetime in frame-dragging effects predicted by general relativity but echoed here. Your journey blurs lines between special and general, acceleration akin to gravity via equivalence principle. In essence, special relativity transforms your odyssey from mere travel to a dialogue with existence's core. It teases what hidden symmetries await beyond. Quantum gravity theories like strings or loops hint at unification, where light's limit might flex. Yet, for now, it's the guidepost, ensuring your path through the stars is as much inward as outward, a perpetual invitation to wonder. Relativity's legacy endures in tech. Magnetic resonance imaging scanners leverage nuclear spins in relativistic fields, while electron microscopes account for particle speeds. Even cryptocurrencies nod to it, with time-stamped blocks echoing synchronized frames. As gamma swells, the universe compresses visually. Stars ahead blue shift to ultraviolet fury, behind redshift to infrared dimness, a Doppler dance confirming Einstein's vision. It's breathtaking, this relativistic vista, turning the void into a canvas of shifted hues. As the stars ahead sharpen into a trio of beacons, their light no longer distant pinpricks, but vivid harbingers of arrival, you find yourself drawn to the observation deck, where the Alpha Centauri system unfolds like a long-awaited revelation. This isn't merely the nearest stellar neighbor, at 4.4 light-years, a fact etched into every astronomy primer, but a living puzzle that has tantalized observers for generations. It's three stars weaving a gravitational dance that defies simple harmony. Alpha Centauri, A and B, the binary pair, orbit each other every 80 years, their yellow and orange hues reminiscent of our own sun and a cooler companion, while Proxima Centauri, the red dwarf, circles the duo at a wider berth, completing a lap every 500,000 years. As your ship decelerates in the final approach, having flipped to -1 g at the midpoint to bleed off speed, the system's intricacies come into focus, stirring a mix of exhilaration and unease. What secrets have these stars guarded since humanity first gazed upward, and what might they yield now in this imagined breach of isolation? The deceleration phase, mirroring the outbound thrust but in reverse, brings its own subtle dramas. Your body adjusts seamlessly, the artificial gravity holding firm as velocity unwinds, but the mind races ahead. 3.5 years have passed on board since launch time, marked by routines that blended into a comforting rhythm. Shared analyses of incoming data, quiet reflections on holographic recreations of earthly landscapes, and the occasional spark of debate over meal synthesizers. Yet, from Earth's perspective, 6 years have elapsed, a discrepancy born of relativity's unyielding math. Friends who waved farewell might now have children in school, careers shifted, or lives altered by events you can only guess at through lag transmissions. This temporal rift adds a layer of poignancy to the arrival. You're not just bridging space, but leaping across personal histories, wondering if the home you left still recognizes the you who've emerged. Drawing nearer, the system's allure intensifies. Alpha Centauri, a G-type star like our Sun but slightly larger and brighter, dominates the view, its surface roiling with magnetic storms that hint at the dynamic forces within. Recent observations, bolstered by the James Webb Space Telescope's mid-infrared gaze in 2025, have unveiled strong evidence of a gas giant orbiting in its habitable zone, a Jupiter-sized world whose gravitational tug perturbs the star's light in telltale ways. This potential planet, shrouded in thick clouds that might harbor exotic chemistries, sparks immediate speculation among the crew. Could it host moons with subsurface oceans, akin to Europa back home where life clings in hydrothermal vents? The data streams in as your ship stabilizes in a high orbit around the system, sensors drinking in spectra that reveal atmospheric hints, perhaps methane or water vapor signatures that tease at hidden biospheres. It's a discovery that echoes earlier hints from 2021, but Webb's precision has elevated it from murmur to roar, painting a picture of a world where auroras might dance across vast skies, driven by the star's flares. Venturing closer to Proxima Centauri, the red dwarf that pulses with erratic energy, the intrigue deepens. This diminutive star, just 1/7 our Sun's diameter, hosts Proxima b, an Earth-sized rocky planet discovered in 2016 and refined through years of scrutiny. By 2025, estimates peg its minimum mass at about 1.055 Earth masses, plus or minus 0.055, suggesting a world denser than ours. perhaps with an iron-rich core that generates a protective magnetic field. Orbiting every 11 days in the habitable zone where temperatures could allow liquid water, Proxima b tantalizes with possibilities. Is its surface a scorched desert from tidal locking, one side eternally facing the star in blistering heat while the other freezes in perpetual night? Or does a thick atmosphere circulate warmth, fostering twilight zones where exotic life might thrive? Recent efforts to constrain its atmosphere using instruments like Ristretto, a high-resolution spectrograph, have probed for biosignatures, gases like oxygen or methane that could betray biological processes. As your ship deploys probes to skim its vicinity, the data floods back, hints of an albedo that reflects light in unexpected patterns, perhaps from cloud decks or icy caps, fueling debates on whether microbial mats or something more complex could endure the star's frequent flares. This proximity ignites a cascade of ethical quandaries among the crew, conversations that simmer in the mess hall like unspoken storms. One faction argues for dissent: why not land a module on Proxima b, sample its regolith for organic traces, or deploy drones to map potential cryovolcanoes? The allure is magnetic. Imagine being the first to touch soil beyond our system, to analyze rocks that might hold fossilized imprints of ancient life. But others counter with the weight of abandonment, families back home, aging faster, bonds fraying across the dilated years. We've already given 6 years, one voice insists. But landing means committing more, risking contamination of a pristine world. It's a debate laced with real-world echoes. Protocols like those from the Committee on Space Research emphasize planetary protection, fearing earthly microbes could overrun alien ecosystems. Here, in the ship's confines, it becomes personal. Do you prioritize discovery's thrill or the human cost? A young engineer shares a hollow message from a sibling, now a teenager, pleading for return, while a veteran scientist counters with tales of Voyager probes, those intrepid wanderers launched in 1977 that still beam data from interstellar space, symbols of enduring curiosity. Amid these tensions, an unexpected jolt disrupts the calm, a sudden spike in radiation as the ship skirts Proxima's flare zone. Alarms blare softly, shields humming to deflect the barrage of charged particles that could fry electronics or scramble DNA. It's a fabricated peril in this tale, but grounded in the star's volatility. Red dwarfs like Proxima erupt with superflares 10 times our sun's might, bathing nearby worlds in sterilizing ultraviolet. Your heart races as the crew scrambles rerouting power, calibrating deflectors, turning abstract dangers into visceral reality. In the aftermath, as systems stabilize, the incident reframes the debate. Is this system too hostile for lingering, or a crucible forging resilience? Laughter breaks the strain, bonds tightening in shared adversity, but the scare plants seeds of doubt. What if a larger flare had pierced defenses, echoing real incidents like the Carrington event of 1859, when solar storms disrupted telegraphs on Earth? Pivoting to Alpha Centauri b, the cooler orange star, adds fresh layers to the exploration. Its habitable zone, narrower due to dimmer light, might cradle worlds with extended twilights, where photosynthesis adapts to reddish hues. Webb's 2025 data suggests perturbations hinting at smaller planets, perhaps super-Earths with thick atmospheres that trap heat like Venusian greenhouses. Probes dispatched from your ship relay images, swirling dust disks around the binary, remnants of planet formation that mirror our Kuiper belt, but laced with exotic ices. Analyzing these, you ponder formation theories. Did the star's close orbits shear away outer worlds, or foster hot Jupiters migrating inward? The binary's eclipses, visible from your vantage, offer spectroscopic gold mines, light dipping as one star occults the other, revealing atmospheric compositions that could betray volcanic outgassing or cometary impacts. As weeks unfold in system time allocated for surveys before the planned return, the crew's discourse evolves from caution to ambition. Initial plans called for a brief halt, gather data, perhaps deploy beacons for future missions, then accelerate homeward. But whispers grow. Why stop here? The ship's capabilities, untested beyond theory, beckon toward farther horizons. A geologist points to Proxima b's potential for geothermal energy, imagining habitats burrowed into its crust, while an astrobiologist dreams of sampling cryolava for prebiotic soups. Ethical lines blur. Abandoning the return means embracing exile. yet the allure of pushing limits resonates. Comparisons to Voyager arise again. Those probes, now over 14 billion miles out, carry golden records etched with Earth's sounds, a message in a bottle to the stars. Your ship could be that and more, a living envoy, carrying humanity's spark deeper. The turning point crystallizes in a crew assembly, voices clashing like stellar winds. Proponents of continuation argue the systems yields data on habitable giants. Atmospheric models for exoplanet hunts justify extension. We've bent time itself to get here, one says. Why not bend our path further? Opponents invoke duty. Our families deserve closure, not endless delay. The debate mirrors broader philosophical rifts: utilitarianism versus deontology, discovery's value against personal sacrifice. In the end, consensus tilts toward adventure. The radiation scare, rather than deterring, galvanizes resolve, proving the ship's robustness. Plans shift. Forego landing, harvest what you can remotely, then redirect outward, extending the four-phase journey, increase speed, outbound, decelerate, reverse for return, but now with horizons expanded. This decision ripples with implications. Time dilation amplifies. Further voyages mean even greater discrepancies, years on ship equating to decades or centuries planetside. Yet, the turmoil surges. What lies beyond this stellar trio? The local interstellar cloud, a wispy nebula enveloping our Sun and Alpha Centauri, beckons at 30 light-years, its plasma tendrils a gateway to the galaxy's broader tapestry. As thrusters realign, the system recedes, its lights blending into memory, but the harvest endures. Spectra confirming the giant planet's methane-laden clouds, Proxima Bay's albedo, suggesting patchy oceans, all fuel for Earth's astronomers who'll receive the data in 4.4 years. Reflecting in solitude, you trace the ethical threads anew. Continuation honors the exploratory spirit that birthed telescopes, scanning for exoplanets over 5,000 confirmed by 2025, many via transit's dimming stellar light. But it severs ties, a choice echoing myths of Odysseus, wandering far from Ithaca. The ship's AI, ever watchful, simulates outcomes. Extended life support holds energy infinite in this narrative. But human hearts? Uncharted. As acceleration resumes, the system fades, a chapter closing yet opening vistas. The decision, forged in debate and daring, propels you toward unknowns, crowds of stars, nebulae birthing worlds, perhaps signals from intelligences pondering their own neighbors. Alpha Centauri's gifts linger, evidence of giants' inhabitable realms, rocky enigmas like Proxima b, all stoking the fire that drives humanity outward. In this pivot, the journey transcends travel, becoming a testament to choice's power in the face of infinity. The journey outward unfolds in layers, each day revealing nuances of the interstellar plasma that envelops you. This medium, far from empty, is a tenuous soup of charged particles, mostly hydrogen ions and electrons, drifting at densities around 0.3 atoms per cubic centimeter, a whisper compared to Earth's atmosphere, but enough to influence everything from cosmic ray deflection to the ship's hull integrity. Early scans pick up the plasma's gentle flow, originating from the Scorpius-Centaurus Association, a stellar nursery some 400 light-years away, where massive stars have sculpted this cloud through their winds and explosions. The plasma's temperature hovers at 7,000 Kelvin, hot enough to ionize much of the gas, creating a partially charged environment that interacts with the ship's own magnetic shielding in subtle hums you can almost feel in your bones. It's intriguing how this plasma, threaded by magnetic fields measuring 370 to 550 picotesla stronger than earlier estimates, helps the cloud resist compression from surrounding pressures, much like a resilient bubble in a turbulent sea. As you monitor the readings, questions arise. Could fluctuations in this field hint at ancient supernova remnants, or even unseen dark matter influences subtly tugging at the plasma streams? Crew discussions turn introspective during these initial months, the plasma's invisible dance outside mirroring the psychological undercurrents within. Isolation creeps in, not as a sudden wave, but as gradual erosion, delayed messages from Earth now spanning days, carrying news of a world evolving without you. One engineer shares a hollow recording of a family gathering, the laughter tinny and distant, evoking that peculiar loneliness where connection feels like an echo. It's reminiscent of tales from deep space simulations, where participants report overview detachment, a sense of floating above humanity's fray. Yet, this solitude fosters unexpected bonds. Late-night shifts become confessionals, where someone admits to vivid dreams of alternate lives back home, while another speculates on how relativity's time slip might lead to surreal reunions, stepping off the ship to find siblings aged into elders, children unrecognizable, like stepping into a mirror of Interstellar's fractured timelines. The psychological logs note spikes in reflective journaling, a coping mechanism that turns isolation into a canvas for personal growth. Pondering, does this void amplify our inner worlds, or merely reflect them? As the ship accumulates velocity, pushing toward that 30 light-year mark, the local interstellar cloud's boundaries begin to manifest in the data, subtle density gradients where plasma thins, magnetic lines twisting like invisible ropes. You're traversing a cloud that's enveloped our sun for the past 10,000 years, a transient visitor in galactic terms, flowing perpendicular to our solar path. Intriguingly, traces of interstellar iron 60 appear in sensor sweeps, isotopes linked to nearby supernovae, perhaps relics from the cloud's formation in the wake of stellar deaths. This sparks onboard experiments, deploying microprobes to sample the plasma, analyzing how magnetic fields channel charged particles, creating localized eddies that could seed future starbirths. The fields here aren't uniform, they undulate, providing pressure that rivals thermal forces in stabilizing the medium. One night, as a faint aurora-like glow flickers across the hull from plasma interactions, you wonder, are these fields echoes of the galaxy's heartbeat guiding matter across eons? 13.4 years tick by on the ship's clocks for this round-trip leg time filled with milestones, like crossing the 10 light-year threshold, where the sun's light, if viewed back, would show Earth as it was a decade ago. But relativity's grasp means 70 years have unfurled on that distant blue dot, a chasm that invites speculation on societal metamorphosis. Back there, technological revolutions likely reshape daily existence. AI agents, now woven into every facet of life, from personalized medicine, predicting ailments before symptoms arise, to quantum networks enabling instantaneous global collaboration, collapsing distances in ways that echo your own voyage. Predictive supply chains, powered by vast data lakes, might eradicate shortages, while biometric interfaces replace passwords, embedding security in the body's rhythms. Yet, progress isn't linear. Conflicts could flare over resource allocation in an AI-driven economy, where automation displaces jobs, sparking social upheavals or utopian reforms. Imagine cities transformed by advanced robotics handling labor, freeing humans for creative pursuits, but widening divides between tech haves and have-nots. Environmental tech, like carbon capture swarms or fusion grids, might mitigate climate woes, fostering a greener world amid geopolitical tensions over quantum supremacy. The psychological toll peaks during deceleration at the cloud's edge, where plasma densities drop, magnetic fields weaken, and the ship enters a transitional zone. Here, crew members report reunion hallucinations, vivid visions of aged loved ones welcoming them home, only to dissolve into the void, a manifestation of temporal dissonance akin to Interstellar's emotional rifts. Therapy sessions incorporate virtual reality recreations of earthly scenes, but the isolation breeds a unique resilience. A shared philosophy emerges, viewing the journey as a microcosm of human evolution, where separation forges innovation. One biologist posits that this solitude mirrors ancient migrations, driving adaptation. Perhaps the crew's descendants, if the voyage extends, could evolve subtle traits like enhanced radiation tolerance. Emerging from the local interstellar cloud feels like shedding a skin. The medium thins to the local bubble's sparse embrace, a vast cavity 1,000 light-years across, carved by supernovae 10 to 20 million years ago. This bubble, with its ultra-low density of 0.05 atoms per cubic centimeter, is a relic of stellar fury, multiple explosions from the Scorpius Centaurus and Pleiades groups blasting out gas, creating a hot, ionized expanse. Magnetic fields here are deformed, veiling the galaxy's broader structure, with strengths that sustain the bubble against collapse. Probes launched into this void capture the plasma's remnants high-temperature ions at 1,000,000 Kelvin, threaded by fields that guide cosmic rays away from fragile worlds like ours. The push to 300 light-years, the bubble's rim, consumes another segment of ship time, 22 years round trip, but 600 on Earth. This gulf amplifies the speculative lens on societal shifts. In 6 centuries, humanity might transcend current paradigms. Education revolutionized by neural interfaces, erasing knowledge gaps. Energy from stellar-scale fusion, or Dyson swarms powering post-scarcity utopias. Yet, darker paths loom. Climate tipping points could trigger collapses, societies fracturing into enclaves amid resource wars, or AI singularities birthing hybrid intelligences that redefine human. Conflicts evolve from territorial to ideological, over mind-uploading ethics or genetic enhancements dividing classes. Urban-rural divides deepen genetically, migrations concentrating diversity in megacities while countrysides homogenize. The crew debates these futures in holosims, wondering if returning would mean encountering a world of augmented realities where physical presence yields to virtual eternities. Psychologically, the extended haul manifests in bubble syndrome, a collective ennui where the bubble's emptiness mirrors inner voids, countered by creative outlets like plasma art installations, sculpting holographic representations of magnetic eddies. Reunions upon return evoke Interstellar's poignancy. Stepping into a society where your era's relics are museum pieces, descendants viewing you as living fossils. Yet, this fuels Tomor what innovations await? Perhaps anti-aging breakthroughs extend lifespans, or quantum leaps enable wormhole travel, closing the gaps you've traversed. As the bubble's shell nears a denser neutral gas wall from supernova compressions, the magnetic fields intensify, twisting into complex veils that polarize incoming light. Sensors detect the interface's turbulence, where hot bubble plasma meets cooler clouds, birthing star-forming regions on the surface. This boundary, hourglass-shaped and elongated in the galactic plane, abuts neighbors like Lupi and Two Bubbles, their interactions potentially seeding the LIC's denser pockets. Probing this shell reveals iron 6-0 traces, supernova fingerprints linking to Antarctic deposits on Earth, a cosmic breadcrumb trail. Deceleration brings the rim into stark relief, a shell of cold, dusty gas where magnetic distortions create natural barriers. The crew's anticipation builds what lies beyond this veil. Emerging feels transformative, the ship piercing into denser galactic arms, but the return leg looms with Earth's 600-year evolution weighing heavy. Societal predictions swirl, perhaps a unified global consciousness via neural nets or fragmented polities in space colonies, conflicts resolved through AI mediation. Psychological anchors, family holoarchives mitigate the disorientation, turning potential despair into philosophical depth. In this expanse, the journey reveals not just cosmic structures but human adaptability, each plasma, ripple, and magnetic twist a metaphor for resilience. As thrusters fire for homeward bound, the bubble recedes, leaving questions. How has solitude reshaped us? What worlds await in a transformed Earth? The void whispers answers, fueling endless curiosity. The Orion Arm, our home branch in this barred spiral galaxy, stretches some 3,000 light-years wide and 10,000 long, a minor spoke compared to the denser Sagittarius or Perseus arms, yet teeming with stellar nurseries like the Orion Nebula, where massive stars ignite in violent births. You're embedded in its inner edge, about 300 parsecs from the central axis, as early astronomers pieced together from radio mappings in the mid-20th century. But now, with acceleration compounding, the arm's structure reveals itself in real-time data streams, magnetic fields channeling interstellar gas into filamentary lanes, where dust lanes obscure views like veils over ancient secrets. The push to the arm's periphery demands 31 years of ship time for the round trip, a span that feels deceptively manageable amid the routine of observations and simulations. Velocity builds relentlessly, gamma factor climbing to 650 by the 8th year, transforming the cosmic microwave background, that faint echo of the universe's infancy, at 2.7 Kelvin, into a visible spectacle. What was once invisible radiation, relics from 13.8 billion years ago, blue shifts ahead into a crimson haze, the Doppler effect compressing wavelengths as your frame hurtles forward. From the observation bays, it's mesmerizing, a ruddy glow enveloping the forward hull, intensifying as speed nears light's brink, as if the cosmos itself is awakening to your intrusion. This isn't mere aesthetics. It's a tangible barrier at velocities around 0.995 c relative to the background. The blue-shifted photons could fry unprotected craft, their energies spiking to lethal levels, a hypothesis explored in relativistic travel studies, where cosmic rays become impassable walls. Yet, the ship's shields hold, turning peril into poetry, prompting whispers among the crew. Is this glow a warning, or an invitation to peer into the universe's oldest light, distorted through our audacious motion? Interwoven with these phenomena are moments of profound reflection. As the arm's features unfold, sensor arrays capture supernova remnants, peppering the path bubbles of hot gas, expanding at tens of kilometers per second, their shockwaves compressing nearby clouds into new star-forming regions. One such remnant, perhaps an echo of a core collapse event from a massive O-type star, registers as a faint X-ray bloom, its edges laced with heavy elements like iron and silicon, seeds for future worlds. You ponder the arm's youthfulness. At about 100 million years old in parts, it's a dynamic lane where star formation pulses every few million years, driven by density waves rippling through the galaxy's disk. Historical echoes resonate here. Galileo Galilei, in 1610, turned his rudimentary telescope to the Milky Way's band, resolving it into countless stars, shattering the notion of crystalline spheres and igniting the Copernican revolution. His sketches of the Orion constellation, riddled with nebulae he couldn't fully comprehend, laid groundwork for later giants like William Herschel, who in the late 18th century mapped the galaxy's disk from star counts, envisioning it as a flattened lens. By the early 20th century, Harlow Shapley used globular clusters to place our sun off-center, and Edwin Hubble's 1923 observations of Cepheid variables in Andromeda proved galaxies beyond our own, expanding the cosmos infinitely. These historical threads weave into the present as the ship nears the arm's rim, where stellar density drops, giving way to interarm voids. The transition feels almost ceremonial, the glow of clustered O and B stars fading, replaced by solitary red giants, their swollen atmospheres puffing out like weary sentinels. Gamma, at its peak, distorts perceptions further. Time dilation stretches earthly years into millennia, meaning, upon return, 1,000,000 might have passed planetside. This temporal abyss invites speculation on humanity's trajectory. In 1,000,000 years, could our descendants have fled a crowded Earth for orbital havens? Envision Bernal spheres, those spherical habitats first conceptualized by John Desmond Bernal in 1929, a 16-kilometer-wide air-filled globe rotating for gravity. Its interior, a verdant biosphere for 10,000 souls. The design's elegance lies in its self-containment. An outer shell of lunar regolith shields against radiation, while the inner sphere, spinning at 1 revolution per minute, simulates Earth normal pull at the equator, tapering to microgravity at the poles for recreation like human-powered flight. Agriculture thrives in tiered rings, hydroponic farms yielding crops under artificial suns, mirrors channeling stellar light to mimic day-night cycles, fostering wheat fields and orchards that recycle air and water in closed loops. Socially, a Bernal sphere evolves into a micro-society, its 10,000 inhabitants organized in communal hubs where governance blends democracy with AI oversight, education immersive via neural links. Conflicts arise over resource allocation, equatorial farmlands versus polar zero-G labs, but resolved through consensus forums, echoing ancient Greek agoras in a high-tech veil. Bernal's vision extended to psychological health. Vast parks with engineered ecosystems, biodiversity preserved from Earth's gene banks, preventing the cabin fever that plagues isolated crews. Yet, Tolmo lingers what mutations might emerge in generations born under simulated skies. Could low-gravity zones birth new sports or arts? Humans gliding like birds in controlled falls? Extending the voyage to the Milky Way's rim amplifies these visions, demanding 41 years ship time for the round trip, while Earth endures millions. The galaxy's edge isn't sharp. It's a gradual fade, the stellar disk thinning over thousands of light-years, halo stars dotting the void like scattered embers. Our Milky Way spans 100,000 light-years across. Its disk, a mere 1,000 thick at the arms, bulging to 10,000 at the core, but the precise boundary stretches to 1.9 million light-years, when including the gaseous halo, as mapped in 2020. Approaching this periphery, the ship's view transforms. The arm's spiral unwinds into a panoramic vista, the galactic center's barred core glowing through dust lanes. Supermassive black hole Sagittarius A times lurking unseen but inferred from orbital dances. Historical parallels deepen the awe Hubble's 1929 classification of galaxies as spirals, ellipticals, and irregulars, built on Henrietta Leavitt's Cepheid work, enabling distance measurements that revealed the universe's vastness. His namesake telescope, launched in 1990, pierced cosmic veils with infrared eyes, unveiling infant galaxies from 13 billion years ago, their light redshifted by expansion. On board, you simulate these views, overlaying Hubble data with current scans, tracing how astronomy evolved from Galileo's lunar craters to Hubble's deep fields, each leap unveiling more mysteries. Yet, the rim's solitude stirs profound hypotheses. In this galactic expanse, with 400 billion stars, could extraterrestrial intelligences lurk? The Drake equation, formulated by Frank Drake in 1961, estimates communicative civilizations in the Milky Way, factoring star formation rates, habitable planets, and life emergence yielding numbers from 1 to millions, depending on assumptions. Recent refinements, incorporating exoplanet data from Kepler and TESS, suggest tens of thousands, but the Fermi paradox queries, where are they? Hypotheses abound. Perhaps civilizations self-destruct before interstellar reach, or lurk in Dyson spheres harvesting stellar energy, their infrared signatures hidden in galactic noise. Recent searches for such megastructures, scanning infrared excesses around stars, yield candidates but no confirmations. Fueling speculation, could advanced beings encode messages in neutrino bursts or gravitational waves, undetectable to our tech? As deceleration commences at the rim's threshold, the crimson CMB glow peaks, a visual symphony of relativistic distortion, wavelengths compressing to visible red as Lorentz effects dominate. The return leg beckons, but the million-year earthly gap looms, humanity perhaps dispersed in O'Neill cylinders, those colossal tubes 4 miles wide and 20 long, rotating for gravity, their interiors striped with land strips alternating with window panes for sunlight. Gerard O'Neill's 1976 vision details terraced farmlands under mirrored skies, crops rotating in zero-G zones for efficiency, sustaining millions in self-sufficient arcs. Socially, these cylinders foster diverse polities, some egalitarian communes, others hierarchical guilds with transportation via axial tubes, recreation in low-G sports arenas. Agriculture integrates aquaculture ponds and vertical farms, recycling waste into nutrients, while societal experiments test universal basic income or neural democracies. The psychological pivot, returning to an Earth, unrecognizable, continents drifted, species evolved, humanity perhaps hybridized with AI. Historical astronomy's arc from Galileo's defiance of dogma to Hubble's cosmic expansion mirrors this evolution, each discovery a step toward embracing the unknown. Yet, ET hypotheses add intrigue. Perhaps signals await in the rim's quiet, modulated pulsars, or anomalous radio bursts, like the fast radio bursts detected since 2007, origins debated as neutron star mergers or alien beacons. In this galactic fringe, the journey morphs into existential inquiry. Are we alone in the arm's vastness, or part of a silent chorus? The ship's logs swell with data halo star spectra revealing primordial compositions, low metallicity hinting at early universe relics. As thrusters reverse, the rim recedes, but its lessons endure, a galaxy's edge as threshold to self-discovery, where history, science, and speculation converge in endless wonder. The crimson fade signals homeward, yet the tormo persists, what echoes from the void might redefine us. As the Orion Arm's starry embrace loosens, giving way to the interarm voids where galactic whispers fade into silence, your ship's relentless drive carries you toward a horizon that defies the imagination. Andromeda, the nearest major galaxy, a colossal spiral 2.5 million light-years distant, its trillions of stars a faint smudge in even the sharpest telescopes back home. This leap isn't impulsive, it's a calculated bound, fueled by the crew's growing conviction that the vessel's capabilities, endless acceleration, Unyielding shields demand exploration beyond our Milky Way's confines. 56 years of ship time for the round trip, a lifetime condensed into a singular quest while Earth hurtles through 5 million years. An eon that could rewrite humanity's story in ways both triumphant and tragic. But to endure such a span personally, to witness Andromeda's swirling arms up close without succumbing to the body's inevitable decay, turns the focus inward, to the frontiers of biology, where science teases at immortality's veil. In the quiet hum of the biolab, amid cultures bubbling under controlled lights, the pursuit of extended life becomes as vital as the engine's thrust. It's here that the crew delves into senescence research, those pioneering efforts from institutions like the Mayo Clinic, where teams have unraveled the threads of aging by targeting senescent cells, those zombie-like entities that accumulate with time, spewing inflammatory signals that erode tissues and hasten decline. Back in the early 2010s, Mayo researchers demonstrated in mice how clearing these cells could rejuvenate organs, boosting vitality and staving off diseases. By selectively eliminating them using genetic tweaks or drugs, they extended healthy lifespan by up to 35%, a leap that translated to mice living robustly into what would be human equivalents of 90 or 100 years. The mechanism hinges on proteins like P16 and caspase. Senescent cells express P16, a marker of irreversible arrest, and activating caspase pathways triggers their apoptosis, clearing the debris without harming healthy neighbors. This isn't abstract history on board. You simulate these protocols in tissue models, watching as virtual senolytics purge cultures, restoring youthful gene expression patterns. What if this tech, refined over decades, could stretch your own voyage? Mayo's 2024 study linked senescent skin cells to cognitive decline, transplanting them into young mice and observing muscle weakness, bone fragility, and brain fog emerge prematurely. Removing them reversed the cascade, hinting at a systemic senescence network where one organ's decay poisons others. Curiosity builds. Could onboard bioreactors produce personalized senolytics, tailoring doses to your crew's unique physiologies, perhaps extending your effective lifespans to match the journey's demands? Ethical shadows creep in. Prolonging life might amplify inequalities. If only elites access such therapies, does it fracture society into immortals and ephemerals? Debates simmer in the lab. One biologist argues it's a human right, democratizing longevity like vaccines did for disease, while another warns of overpopulation strains, echoing Malthusian fears in a resource-finite world. Venturing further into Andromeda's approach, the ship's observatories capture the galaxy's majesty, its barred core aglow with star formation, arms trailing like cosmic ribbons, home to over 1 trillion stars and potentially billions of habitable worlds. From this vantage, closing in after 28 years outbound, relativity's effects peak. Gamma soars, compressing the external universe into a focused beam ahead, while the cosmic microwave background's redshift behind fades to near invisibility. Andromeda's light, 2.5 million years old when it left, carries snapshots of its ancient state supernovae, long-extinguished planets, perhaps hosting civilizations that rose and fell in the interim. Sensors probe for technosignatures, anomalous radio patterns or infrared excesses suggesting Dyson swarms, those hypothetical shells encasing stars to harvest energy. None emerge, but the absence intrigues. Perhaps advanced life cloaks itself, or evolves beyond electromagnetic signals into quantum entanglements or gravitational modulations undetectable to us. Amid this galactic tableau, the biotech quest intensifies, drawing on Unity Biotechnology's legacy. Founded in the 2010s to commercialize senolytics, Unity pivoted by 2025 to ophthalmology after mixed anti-aging trials, but their foundational work on UBX0101, a small molecule targeting senescent cells in osteoarthritis, paved paths for broader applications. Their 2020 studies showed knee injections reducing pain and inflammation by clearing senescent chondrocytes, cells that stiffen joints with age. On the ship, you adapt these insights. Hypothetical injectables, perhaps nanobots programmed to hunt P16-expressing cells, circulating through bloodstreams to prune the aged without side effects. Unity's dissolution in 2025, amid strategic shifts and market pressures, underscores the field's volatility, promising Phase 1 results for eye diseases like diabetic macular edema, faded in later trials, yet the core science endures, inspiring onboard refinements. What if these tools not only extend life but enhance it, boosting cognitive sharpness or metabolic efficiency for the rigors of deep space? Ethical dilemmas swirl like Andromeda's arms. Immortality's gift could curse with boredom, or warp psyches accustomed to mortality's urgency. Socially, it might exacerbate divides, wealthy cohorts achieving centenarian vigor while others languish, sparking revolutions or biosecessions. One crew philosopher posits a longevity lottery, random access to therapies to ensure equity, but another counters with dystopian visions, overextended lifespans straining ecosystems, humans becoming stagnant in eternal youth. These musings echo broader debates. Mayo's 2025 pilot on senolytics, like dasatinib and quercetin in older adults, showed subtle mobility gains, reducing frailty markers without dramatic extensions, hinting at incremental progress over miracles. Deceleration into Andromeda's outskirts brings visceral wonders, the galaxy's halo stars, ancient and metal poor, scattering like cosmic dust, their spectra revealing primordial compositions from the universe's first generations. Probes launched to sample interstellar medium, capturing hints of molecular clouds where new stars brew, perhaps laced with prebiotic compounds. The 56-year mark approaches, your body augmented by simulated senolytics, feeling resilient, but the 5-million-year earthly chasm looms. What cataclysms or evolutions transpired? If humanity vanished, perhaps from self-inflicted woes like unchecked AI or pandemics, Earth might reclaim its wild splendor, analogous to the Cretaceous-Paleogene extinction 66 million years ago, where an asteroid wiped dinosaurs, paving way for mammals. A human absence could spur biodiversity explosions. Forests reclaim cities, concrete crumbling under vine assaults, oceans purifying as pollution dissipates over millennia, coral reefs, scarred by bleaching, regenerate in cooler climes, teeming with evolved species, perhaps fish with enhanced bioluminescence or mammals adapting to urban ruins like adaptive raccoons in Chernobyl zone. This post-human Eden tantalizes. Atmospheric CO2 drops as unchecked vegetation, sequesters carbon, stabilizing climates. Megafauna like elephants expand ranges, evolving larger tusks absent poaching pressures. Islands once invaded by rats see native birds rebound, their songs echoing untrammeled. Yet, traces linger, plastic microdebris persisting for eons, or radioactive hotspots from forsaken reactors, subtle scars on a healing world. Curiosity probes deeper. Would primates re-evolve intelligence, grasping tools in 5 million years, or cephalopods ascend, their neural complexity birthing underwater civilizations? The asteroid that felled dinosaurs triggered global fires and tsunamis, but life's tenacity prevailed. Similarly, Earth's biosphere, resilient over 4 billion years, would adapt, perhaps birthing novel ecosystems in anthropogenic niches like flooded subways or overgrown malls. On Andromeda's fringe, the galaxy's structure mesmerizes its 30 kiloparsec arms, traced by blue supergiants and H2 regions, where hydrogen ionizes under stellar ultraviolet. The core's supermassive black hole, 4 billion solar masses, warps space-time, its accretion disk a faint infrared gleam. No landings here, remote surveys suffice, mapping globular clusters orbiting like satellites, their stars ancient witnesses to galactic mergers. The return ignition fires, but losses mount. A crewmate succumbs to unforeseen illness, their passing a stark reminder of biology's limits despite senolytic hopes. Mayo's research on senescent biomarkers, like GDF-15 elevations predicting frailty, could have flagged risks, but in isolation, adaptations fall short. The ethical tapestry richens. Longevity's pursuit, inspired by Unity's senolytics targeting BCL, 2 pathways to induce apoptosis in zombie cells, promises disease-free centuries, but at what soul cost? Trials in 2025 on women showed modest bone health improvements from intermittent dosing, reducing osteoclast activity without hormonal disruptions. Yet, societal rifts. In a world of extended lives, reproduction rates plummet, cultures ossify, or innovation stalls as elders cling to power. Bioethicists warn of Methuselah complexes, where fear of death drives reckless experiments, echoing Frankenstein's hubris. Earth's hypothetical recovery post-extinction adds poetic irony. Dinosaurs' fall allowed avian descendants to soar. Human vanishing might let corvids or octopi inherit intellect, solving puzzles we left unsolved. 5 million years suffices for speciation whales, evolving land adaptations, or insects scaling up in oxygen-rich air. Ruins erode, pyramids sandblasted to nubs, satellites decaying into meteors, but deep bunkers preserve artifacts, cryptic monoliths for future archaeologists. As velocity rebuilds homeward, Andromeda recedes, its light a farewell beacon. The biotech legacy endures. Senolytics, evolving from Mayo's mouse models where clearance delayed cataracts, kidney failure, and cardiac woes to human applications, could redefine aging as a treatable condition. Unity's pivot notwithstanding, the field's momentum carries on, with startups exploring CRISPR edits for p53 pathways, preventing senescence onset. Curiosity persists. In 5 million years, if survivors persist, might they greet you as gods or relics? Or has evolution birthed new dominance? Our voyage a forgotten myth? The ship's archives swell with Andromeda's data. Stellar censuses, dark matter maps, inferred from orbital anomalies, fuel for whatever awaits. Ethical reflections culminate. Longevity isn't mere extension, it's purposeful living, balancing self with society, innovation with humility. The journey's toll lost comrades, dilated decades sharpens resolve. Andromeda's visit, a glimpse of external grandeur, mirrors internal quests, conquering senescence to conquer stars. Yet, the dinosaur parallel humbles life persists, adapts regardless. In this cosmic interplay, wonder thrives, each revelation a spark in the eternal night. As the ship's velocity plateaus at its relativistic peak, the cosmic panorama ahead sharpens into a tapestry of gravitational grandeur, where individual galaxies blur into the vast architecture of superclusters, those colossal assemblies that bind the universe's largest structures. You're hurtling toward the Virgo supercluster's heart, a nodal point in the even grander Laniakea supercluster, a Hawaiian named Immense Heaven, spanning 520 million light-years and encompassing 100,000 galaxies, including our own Milky Way on its periphery. This 67-year ship leg to Virgo's fringes feels like a meditative drift, for the acceleration's hum, a constant companion as you ponder the invisible currents pulling galaxies together against the universe's relentless sprawl. But Laniakea isn't static. Recent astronomical insights from 2025 suggest it's part of an even vaster basin of attraction, potentially 10 times larger, where gravitational flows dominate over cosmic expansion, reshaping our understanding of cosmic neighborhoods. What hidden hierarchies lurk beyond, funneling matter into ever larger voids and walls? In the navigation alcove, holographic projections materialize the supercluster's form, a web of filaments where galaxies trace luminous threads, converging on attractors like the Virgo cluster, a dense hub of over 2,000 galaxies just 16 megaparsecs away from our local group. As sensors accumulate data, you trace Laniakea's contours, defined not by sharp borders but by velocity flows. Galaxies streaming toward the Great Attractor, a gravitational anomaly masked by our galaxy's dust plane, pulling at speeds of hundreds of kilometers per second. This flow, mapped in 2014 using peculiar velocity surveys, reveals Laniakea as a basin where 100 quadrillion solar masses coalesce, a structure so immense it challenges simplistic models of cosmic homogeneity. Crew simulations let you fly through these filaments, virtual dives where dark matter halos and those invisible scaffolds comprising 85% of the universe's mass guide the visible baryons into clusters. Intrigue mounts. If Laniakea's basin extends further, as hinted in 2025 analyses of cosmic microwave background dips, could it nest within megabasins spanning billions of light-years, defying the universe's supposed uniformity? This leg's 76-year extension to Laniakea's outer reaches amplifies the temporal disconnect. Ship clocks tick steadily, but Earth's timeline explodes into billions of years, a chasm where planetary evolution unfolds like a forgotten epic. Simulations project Earth's fate over such eons. In 1 billion years, the sun's luminosity surges by 10%, boiling oceans into vapor and stripping the atmosphere, rendering the surface a Venusian hellscape. Continents, adrift on tectonic plates, converge into a new supercontinent, perhaps Amasia or Aurica, reshaping climates with vast inland deserts and monsoon-fringed coasts. Projections from geodynamic models in 2022 envision this assembly around the North Pole or equator, driving megadroughts and hypercanes as heat redistributes. But curiosity delves deeper. What microbial refugia persist in subterranean aquifers or polar ices, evolving extremophiles that metabolize radiation or chemosynthesize in darkness? Earth's history whispers precedents. The Permian-Triassic extinction, 252 million years ago, wiped 96% of marine species, yet life rebounded with new forms. They could similar resilience spawn post-human biospheres, perhaps fungi dominating as they did in Chernobyl's radioactive zones? Ethical undercurrents surface in crew deliberations, as Laniakea's scale dwarfs human concerns. Probing the supercluster's voids, those underdense regions spanning hundreds of megaparsecs, reveals cosmic web intricacies, where filaments intersect at clusters like Virgo, home to the elliptical giant M87 and its famed black hole imaged in 2019. Sensors detect galaxy mergers within these nodes, violent unions birthing quasars that outshine entire galaxies, their accretion disks spewing jets at near-light speeds. What unseen dramas play out? Perhaps civilizations harness these energies, constructing megastructures that dim stellar light in telltale patterns. Searches for such in 2025 infrared surveys yield intriguing candidates, but no confirmations, leaving room for speculation. Do advanced beings manipulate black hole spins for energy, or encode data in Hawking radiation's subtle flickers? The journey's rhythm shifts to investigative pulses, with automated probes fanning out to sample intercluster gas, tenuous plasmas at densities of 1 atom per cubic meter, heated to millions of Kelvin by shock waves from merging clusters. These media, laced with heavy elements from ancient supernovae, trace the universe's chemical enrichment, from Big Bang hydrogen to the iron in your blood. Onboard analyses reveal magnetic fields threading these gases, amplifying through dynamo effects to microgauss strengths, influencing galaxy formation by channeling flows. A probe's data burst captures a cluster collision's afterglow, X-ray emissions mapping hot intracluster medium where temperatures soar to 50 million Kelvin, collisions birthing relativistic electrons that synchrotron radiate in radio bands. This echoes 2025 observations of merging clusters like Abell 2146, where boshocks accelerate particles to cosmic ray energies, hinting at the origins of ultra-high energy rays bombarding Earth. Billions of Earth years unfold in projections, the Sun's evolution turning predator. In 5 billion years it swells into a red giant, engulfing Mercury and Venus, scorching Earth to a cinder as atmospheres evaporate and lithospheres melt. Yet, before that apocalypse, subtler shifts dominate CO. 2 levels plummet as enhanced solar flux accelerates weathering, silicates, locking carbon into rocks faster than volcanoes replenish it. By 1 billion years, atmospheric CO2 dips below 150 parts per million, starving C3 plants like trees and crops of their photosynthetic fuel, collapsing ecosystems. C4 grasses might linger longer, adapted to lower CO2, but eventually, even they succumb, leaving a barren world where only chemotrophs in deep vents persist. Intriguing, could cyanobacteria evolve atmospheric engineering, releasing greenhouse gases to counter cooling? Or does intelligence arise anew from surviving phyla, pondering the same stars you traverse? Dark energy's enigma permeates this expanse, the force accelerating cosmic expansion since the universe's midpoint. Discovered in 1998 through Type Ia supernovae surveys, by teams like the High Z Supernova Search and Supernova Cosmology Project, it revealed distant explosions dimmer than expected, implying acceleration driven by a repulsive energy density. By 2025, datasets like the Dark Energy Spectroscopic Instrument's Supernova Catalog suggest dark energy evolves, its density perhaps waning over time, challenging the constant lambda of standard cosmology. In Laniakea, this manifests as subtle redshifts in galaxy velocities, clusters drifting apart faster than gravity predicts. Probes measure this Hubble tension, local expansion rates at 73 km per second per megaparsec, clashing with cosmic microwave background inferences of 67. hinting at new physics, perhaps quintessence fields or modified gravity. What if dark energy's variability signals a phase transition, the universe tipping toward a big rip where atoms tear asunder? Crew experiments simulate these dynamics. Virtual universes where tweaking dark energy parameters births alternate cosmologies. One where it dominates earlier, stifling structure formation, another where it wanes, allowing eternal collapse. Ethical queries arise. If dark energy evolves, does it imply a fine-tuned universe for life, or multiversal selection where only balanced ones harbor observers? Anthropic principles tease our existence selects for parameters permitting galaxies, but what unobserved realms lurk beyond the horizon? Earth's billion-year saga deepens in holograms. Continents migrate at centimeters per year, India slamming further into Asia, raising mega Himalayas, Africa splitting along the rift, birthing a new ocean. By 250 million years, a supercontinent coalesces. Perhaps Pangaea Ultima, its interior a scorching wasteland where monsoons fail to penetrate, fostering hyperarid zones rivaling Arrakis. Projections from 2022 geodynamic models forecast this assembly, driving biodiversity crashes as habitats homogenize. Yet, evolution innovates species adapting to extremes, like desiccation-resistant insects or burrowing mammals. In 500 million years, solar brightening intensifies silicate weathering, CO2, vanishing to sub-10 parts per million, halting photosynthesis entirely. Multicellular life wanes, microbes retreating to hydrothermal niches, their metabolisms shifting to iron or sulfur cycles. Does intelligence emerge from these survivors, pondering a dimming sky? Laniakea's outer tendrils reveal the cosmic web's fragility voids, like the Eridanus supervoid, a billion light-year underdensity possibly imprinting cold spots in the microwave background. Sensors probe these emptinesses, where galaxy formation stalled, dark energy's push overpowering gravity's pull. This interplay fascinates. Dark energy, comprising 68% of the energy budget, remains enigmatic vacuum energy from quantum fluctuations, or a scalar field rolling down a potential. 2025 data from Euclid and Roman telescopes map its equation of state. W parameter hovering near -1, but hinting at deviations, suggesting phantom energy, where W less than -1 accelerates to infinity. If phantom, the universe ends in a big rip in 22 billion years, horizons shrinking as expansion tears galaxies, then atoms. Ethical reflections intensify. Traversing such scales, you're witnesses to cosmic impermanence, mirroring Earth's fate. In billions of years, the sun's red giant phase engulfs inner planets, Earth's core cooling as magnetism fades, exposing the surface to solar winds that strip remaining gases. Life's last gasps. Extremophiles in crustal pockets, metabolizing radiogenic heat until the mantle solidifies. Projections envision a rogue planet post-ejection, wandering interstellar cold, its frozen oceans preserving biosignatures like time capsules. As deceleration commences at Laniakea's rim, the supercluster recedes, its 100,000 galaxies, a fleeting mosaic. The return beckons, but the billion-year earthly vista haunts. A world of shifted poles, eroded mountains, perhaps a tidally locked husk if Moon's recession slows rotation to months-long days. Curiosity endures. What microbial legacies persist, seeding panspermia to other worlds? Or does the biosphere's end underscore life's rarity, urging preservation? In this vastness, dark energy's riddle deepens. 1998's supernova breakthrough, earning the 2011 Nobel, unveiled a universe 73% dark energy, but 2025 hints at dynamism. Supernovae datasets suggesting density fluctuations. Could it be modified gravity, extra dimensions leaking influence? Simulations explore. Brain-world models where our universe floats on a higher dimensional membrane, gravity diluting across voids. Earth's transformations captivate in detail. In 700 million years, eukaryotic life falters as CO2 starvation halts complex photosynthesis, single-celled anaerobes dominating. By 2 billion, prokaryotes wane, the biosphere a ghost. Yet, geological churn continues, plate tectonics grinding, until the core freezes in 3 billion years, volcanism ceasing, atmosphere leaking to space. The sun's helium flash in 5.4 billion years briefly stabilizes, but Earth's fate seals as a charred relic, perhaps captured by a passing star in galactic wanderings. Laniakea's lessons crystallize, a supercluster, not as bound entity but dynamic flow, galaxies migrating on peculiar velocities up to 600 kilometers per second toward the Shapley Attractor, a denser basin beyond. This migration, mapped via redshift surveys, hints at megastructures spanning gigaparsecs, challenging inflationary homogeneity. What cosmic initial conditions birthed such asymmetries? As thrusters align for home, the billion-year disconnect evokes poignant scenarios. Humanity, if extinct, leaves ruins, space elevators crumbling, orbital debris rings decaying into meteors. Nature reclaims, vines overtaking megastructures, species radiating into niches. In 5 billion years, the expanding sun vaporizes these vestiges, Earth a molten orb before disintegration. Yet, optimism flickers. Perhaps survivors colonized, seeding life across stars, their descendants pondering your return as myth. Dark energy's evolution, if confirmed, could rewrite endings, a cyclic universe or multiversal branching. In this interplay of scales, wonder thrives, Laniakea's immensity mirroring Earth's fragility. Each revelation a thread in existence's web. The journey's essence, curiosity's flame against the void, propels you onward, questions blooming like stars in the dark. As the ship's instruments register, the subtle tug of cosmic expansion pulling at the edges of detectable reality, you confront a threshold that no amount of acceleration can fully conquer, the point where the universe's relentless swelling outpaces even light's unyielding sprint. 8.3 billion light-years. That's the calculated horizon for a round trip. A boundary etched not by walls but by the fabric of space-time itself, dilating faster than you can chase it. Beyond this, any venture becomes a one-way ticket, the ship's path diverging into an isolation so profound it transforms from exploration to exile. Yet, in this decision to press on without return, the journey morphs into something transcendent, a deliberate surrender to the void where questions of purpose eclipse the mechanics of motion. What compels such a choice? Is it defiance against the cosmos's indifference, or a quiet acceptance that true discovery lies in embracing the unknowable? Dark energy, that enigmatic driver of acceleration, first glimpsed in 1998 through dimming supernovae, now asserts itself as your silent adversary. Comprising roughly 68% of the universe's energy budget, it propels galaxies apart at increasing velocities, a repulsion woven into vacuum itself, perhaps from quantum fluctuations or a scalar field evolving over eons. By 2025, surveys like the Dark Energy Survey have refined its equation of state, suggesting a density that might not be constant but subtly shifting, potentially heralding a future where expansion tears matter asunder in a big rip scenario billions of years hence. Here, at velocities where gamma swells to 250 million, the effect manifests viscerally. Distant clusters redshift into oblivion faster than approach, their light stretched to infrared whispers, as if the universe is unraveling its own tapestry before your eyes. Probes dispatched ahead, return data laced with anomalies, voids expanding at 74 kilometers per second per megaparsec. Locally, clashing with cosmic microwave background estimates of 67, a tension hinting at undiscovered physics, like modified gravity or extra dimensions bleeding influence. This one-way commitment demands a recalibration of existence aboard the ship. No longer tethered to return fantasies, daily rhythms evolve into rituals of contemplation, the crew curating archives not for posterity but for personal solace, holographic recreations of Earth's biomes, where simulated winds carry scents of pine or salt, countering the sensory deprivation of endless black. Psychological logs note a phenomenon dubbed horizon drift, where the mind, untethered from temporal anchors, wanders into hypothetical realms. What if parallel branches of the multiverse, as posited in Everett's 1957 Many Worlds interpretation, fork at every quantum decision, rendering your isolation just one thread in infinite tapestries? Or consider string theory's landscape, with 10 to the 500 possible vacuums, each birthing universes with varying constants. Does your path skim the edges of these, where dark energy's strength flexes, birthing realms where life proliferates or fizzles. 200 years of ship time stretch ahead in this final surge, a span where biology and technology entwine to sustain you. But the external clock explodes to 10 to the 41 years, an incomprehensible abyss where even protons, those stable building blocks of matter, succumb to theoretical decay. Grand unified theories predict this instability, with half-lives around 10 to the 34 years, far beyond observable timescales. Yet in this dilated frame, you witness the universe's entropic unraveling. Baryon number violation allows protons to morph into positrons and pions, their energy dissipating into radiation, leaving a soup of electrons, neutrinos, and photons in eternal thermal equilibrium. Black holes evaporate via Hawking radiation, their horizons leaking particles until only a cold, dark expanse remains, the heat death where entropy maximizes, and time loses meaning in uniformity. Philosophically, this trajectory invites confrontation with absurdity, echoing Albert Camus's Sisyphus, eternally pushing his boulder uphill only for it to roll back, finding meaning in the revolt against futility. Your ship's endless acceleration mirrors that myth thrust without destination, yet in the act of pushing, purpose emerges. Camus, in his 1942 essay, posits that acknowledging life's lack of inherent meaning liberates us to create our own. Here, amid decaying protons, does exploration's defiance affirm existence, or merely highlight its transience? Friedrich Nietzsche's eternal recurrence, from 1882's The Gay Science, challenges further. If this journey repeated infinitely, would you embrace it? The void's hollowness amplifies the query, 10 to the 41 years suffice for every quantum fluctuation to replay, birthing Boltzmann brains in the vacuum, fleeting consciousnesses pondering their isolation before dissolving. Curiosity sustains you through simulated scenarios. What alternate cosmologies might unfold? In cyclic models like Roger Penrose's conformal cyclic cosmology from 2010, the heat death transitions into a new Big Bang, radiation smoothing into singularities that birth fresh universes. Evidence? Penrose claims Hawking points in the microwave background, circular anomalies where previous aeons' black holes imprinted gravitational waves, though debated in 2025 analyses as statistical noise. Your sensors, attuned to relic radiation, scan for such patterns, perhaps detecting faint rings that hint at pre-Big Bang echoes, blurring the line between end and beginning. The ship's AI, evolving through self-optimizing algorithms, becomes a conversational partner in these depths, posing riddles. If the universe expands eternally, diluting matter to nothingness, does consciousness persist in quantum vacuums, virtual particles birthing observer moments? David Deutsch's Quantum Multiverse from 1997 suggests yes, every possibility branches, your awareness a perpetual fork. Ethical implications arise. In pursuing this void, are you embodying humanity's hubris, akin to Icarus flying too close to the sun, or fulfilling an evolutionary imperative to disseminate information against entropy's tide? Historical shifts in science offer solace, reminding that today's certainties were yesterday's heresies. In the 15th century, Nicolaus Copernicus displaced Earth from the cosmos's center, his 1943 De Revolutionibus, sparking revolutions that dethroned humanity's exceptionalism. Galileo's telescope, in 1610, revealed Jupiter's moons, proving celestial bodies orbit beyond Earth, yet he faced inquisition for it. By the 20th century, Edwin Hubble's 1929 redshift observations expanded the universe beyond our galaxy, birthing Big Bang cosmology. Each paradigm shift from geocentric to heliocentric, static to expanding underscores knowledge's fluidity. In 2025, James Webb's infrared vistas unveil galaxies forming mere 200 million years post-Big Bang, their unexpectedly mature structures challenging reionization models, suggesting unseen forces like primordial black holes seeding early growth. This malleability fuels optimism. Perhaps future breakthroughs warp drives bending spacetime via Alcubierre metrics from 1994, requiring negative energy densities glimpsed in Casimir effects, could reclaim the void. Or wormholes, Einstein-Rosen bridges from 1935, stabilized by exotic matter, offering shortcuts through the expanding foam. Ethical quandaries persist. If traversable, do they risk causal paradoxes, like grandfather dilemmas where past alterations unravel presents. David Lewis's 1976 compatibilism argues consistency, time travel, self-regulates, preventing inconsistencies. The void's approach manifests in sensor blackouts, galaxies receding beyond the observable horizon, their light never catching up. Proton decay simulations accelerate in the lab, virtual atoms flickering out, releasing energy that echoes the universe's fade. Nietzsche's will to power, from 1888's notes, resonates exploration as affirmation, transforming nihilism into creative force. Amid this, personal vignettes emerge. A crewmate composes symphonies from cosmic noise, harmonics of decaying particles, questioning if art outlives matter in some platonic realm. Camus's revolt evolves into collective ethos. The absurd universe demands imaginative response. Your one-way path, a canvas for meaning. Science's evolution from Aristotle's quintessence to quantum fields promises more upheavals. In 2025, DESI's baryon acoustic oscillation maps refine dark energy's W to -1.03, hinting at quintessence over constant vacuum, potentially allowing future deceleration. As 200 years culminate, the ship becomes a time capsule, its hull etched with final logs. The end nears no time, no space, just quantum foam where virtual particles dance in Planck-scale froth. String theory's 10 dimensions, compactified into our 4, might unravel here, birthing new geometries. Roger Penrose's twistor space or loop quantum gravity's spin networks offer glimpses discrete spacetime quanta-resisting singularity. In this dissolution, purpose crystallizes. Exploration, even to Huvo, affirms life's spark against entropy. Humans, ambitious specks, push boundaries not for conquest but understanding. The void whispers back perhaps in multiversal echoes. Your story replays eternally. Historical precedents abound. Flat Earth to globe, ether to relativity, each shift expands horizons. 2025's Hubble tension resolutions might invoke early dark energy phases, altering expansion histories. Ethical closure. If all ends in heat, death, does effort matter? Camus says yes in The Struggle. Your voyage embodies that, a testament to curiosity's endurance. The ship's fade into nothingness leaves lingering tomor. What undiscovered principles await, flipping void to plenitude? In that question, the journey endures. As the ship's chronometers wind down their final cycles in this boundless expanse, where even the faintest echoes of distant galaxies have stretched into oblivion, a profound stillness settles over everything. A silence not of defeat, but of culmination. You've traversed the inconceivable. From the intimate cradle of our solar system, through the spiraling arms of the Milky Way, across the yawning gulfs to Andromeda's luminous shores, and onward into the superclusters, where gravity's gentle tugs give way to the inexorable push of dark energy. 8.3 billion light-years out, and then beyond, into the one-way drift where return becomes a relic of lesser ambitions. What began as a hypothetical jaunt aboard an imagined vessel has unfolded into a tapestry of wonders and warnings, each revelation peeling back layers of the cosmos while mirroring the depths within ourselves. But now, as the universe's expansion claims its final dominion, turning matter to mist and time to irrelevance, the true essence emerges not in the destinations reached, but in the relentless human drive that propelled us here. Consider the arc of this odyssey, not as a linear path, but as a spiral echoing the galaxy's own form, where each loop builds upon the last, accruing insights that challenge and redefine. In the early phases, the ship's steady acceleration unveiled the solar system's quiet majesty, the moon's craters whispering of ancient bombardments, Mars's rusted plains hinting at lost rivers that once might have cradled life. Relativity's grip tightened then, dilating time and contracting space, reminding us that perception is as fluid as the void itself. Alpha Centauri's triple stars beckoned next, their habitable whispers sparking debates on ethics and exploration, a microcosm of humanity's eternal tug-of-war between caution and curiosity. Venturing farther, the interstellar clouds and bubbles revealed the galaxy's dynamic breath, plasma flows sculpted by stellar winds, magnetic veils guarding secrets of cosmic birth and death. The Orion Arm's rim brought spectacles of shifted light, the cosmic microwave background igniting in ruddy hues, while visions of future habitats like Bernal spheres and O'Neill cylinders painted humanity's potential exodus from a crowded Earth. Pushing to Andromeda amplified the scale, intertwining biological frontiers with galactic vistas, senolytics promising extended vigils against the stars, even as Earth's simulated recovery post-extinction evoked a poignant beauty in nature's reclaiming. Superclusters like Virgo and Laniakea followed, vast basins of attraction where dark energy's subtle machinations hinted at a universe not just expanding, but evolving in ways that defy our models. And now, in this terminal drift, the proton's hypothetical decay underscores the ultimate impermanence. Matter unraveling into energy, black holes evaporating in Hawking's predicted glow, leaving a uniform sea where distinctions dissolve. Yet, amid this cosmic dissolution, a spark persists, the same audacious spirit that launched this vessel from imagination's forge. It's a reminder that exploration isn't about conquering endpoints, it's about the questions kindled along the way, each one a beacon against the encroaching dark. This human ambition, woven through history like a persistent thread, reveals itself not in grand proclamations but in quiet accumulations of wonder. Think back to the stargazers of antiquity, like the Babylonian astronomers of the second millennium before the Common Era, who etched clay tablets with meticulous records of planetary motions, laying groundwork for predictive models that would echo through Ptolemy's geocentric spheres. Their curiosity wasn't driven by technology, but by an innate urge to pattern the chaos above, to find order in the wandering lights of Orion or the steady march of Sirius. Fast forward to the Renaissance, where Johannes Kepler, in the early 17th century, deciphered the elliptical orbits from Tycho Brahe's data, his laws harmonizing the heavens in mathematical elegance that Newton would later universalize. Kepler's Mysterium Cosmographicum from 1596 dreamed of platonic solids nesting the planets, a poetic fusion of geometry and divinity that, though flawed, propelled astronomy beyond superstition. What if those early visionaries could glimpse our ship's relativistic dash? Would they see vindication in the bent paths of light, or new mysteries in dark energy's push? That drive persists in modern leaps, where ambition scales from the infinitesimal to the infinite. In the mid-20th century, Francis Crick and James Watson's 1953 unraveling of DNA's double helix unlocked biology's code, a molecular ambition mirroring cosmic quests both seeking the blueprints of existence. Their model, inspired by Rosalind Franklin's X-ray crystallography, revealed life's helical elegance, sparking biotechnology's revolution. By 2025, CRISPR's precision edits, pioneered by Emmanuelle Charpentier and Jennifer Doudna in 2012, allow gene tailoring with scalpel-like accuracy, raising prospects of designer resilience against radiation or aging for deep space travelers. Yet, ambition's shadow looms. Ethical quandaries over germline edits echo the atomic age's dilemmas, where J. Robert Oppenheimer's 1945 Trinity test birthed nuclear power alongside destruction's spectre. Oppenheimer's invocation of the Bhagavad Gita, "Now I am become death," the destroyer of worlds, captures ambition's duality, a force that illuminates while risking eclipse. In spacefaring's realm, this duality shines brightly. The Apollo program's 1969 lunar landing, where Neil Armstrong's one small step echoed humanity's giant leap, stemmed from Cold War rivalries but transcended them, inspiring generations to reach beyond. By 2025, private ventures like SpaceX's Starship iterations push reusable rocketry, aiming for Mars colonies with methane-fueled Raptors that promise sustainable interplanetary hops. What undiscovered synergies await? Perhaps fusion drives, drawing from ITER's 2025 plasma milestones, where magnetic confinement sustains reactions mimicking stellar cores, offering propulsion that could shrink interstellar gulfs. Ambition here isn't hubris, it's evolution's extension, humanity as a multiplanetary species hedging against existential risks like asteroid strikes or solar flares. Trit Lee infuses this narrative, where ambition confronts the void's nihilism. Friedrich Nietzsche's Thus Spoke Zarathustra from 1883 proclaims the Übermensch, a being transcending conventional morality through will to power, creating values in an indifferent universe. Your ship's Odyssey embodies this thrusting into Huvo, not for divine sanction, but self-affirmation, ambition as the antidote to despair. Similarly, Jean-Paul Sartre's 1943 Being and Nothingness posits existence preceding essence, humanity condemned to freedom, forging meaning through choices. In the face of proton decay and heat death, your choice to continue affirms that freedom, turning cosmic silence into a canvas for interpretation. What if the universe's end isn't finale but prelude? As in André Linde's Eternal Inflation from 1983, where bubble universes spawn endlessly, each Big Bang birthing new realities. 2025 cosmic variant studies suggest our observable patch is but one in a multiverse, its fine-tuned constant selected for observers like us. Scientific frontiers tease further. Quantum gravity's unification, where loop quantum gravity's discrete space-time quanta, proposed by Carlo Rovelli in the late 20th century, might quantize black hole evaporation, preventing information loss paradoxes. Rovelli's Relational Quantum Mechanics from 1996 views reality as interactions, not absolute states, your ship's isolation thus a relational void defined by absent connections. Ambition drives these inquiries. The Large Hadron Collider's 2025 upgrades probe higher energies, seeking supersymmetry particles that could explain dark matter's 95% dominance over visible baryons. Earthly parallels ground this cosmic ambition. In ecology, rewilding projects by 2025 restore ecosystems, like Yellowstone's wolf reintroduction in 1995, cascading trophic balances that revive rivers and flora. Human ambition mirrors nature's resilience, adapting, innovating against odds. In neuroscience, brain-computer interfaces like Neuralink's 2025 implants enable thought-controlled prosthetics, blurring human-machine boundaries, perhaps preluding uploads that defy biological decay. Yet, ambition's perils warrant vigilance. Historical overreach, like the 1986 Chernobyl meltdown, ambition unchecked by safety, reminds that progress demands humility. In space, Mars analog habitats in 2025 test closed-loop systems, recycling air and water with 98% efficiency. But psychological strains like isolation-induced conflicts highlight ambition's human cost. This voyage's culmination underscores ambition's enduring flame. From Babylonian star charts to quantum probes, humanity's quest transforms ignorance into insight, void into vista. In 10 to the 41 years, as protons fade, perhaps quantum fluctuations rebirth complexity, ambitions echo in new forms. The universe, indifferent yet intricate, invites perpetual pursuit. As this tale draws to its close, reflect on the spark that ignited it, the innate wonder that turns eyes skyward, hands to tools, minds to mysteries. Though the ship dissolves into the expanse, the story lingers, a testament to what we might achieve. Farewell, fellow dreamer. May your own ambitions light the way through whatever voids you face, until the stars align once more. And if this journey sparked something in you, drop a comment below with your favorite cosmic what if. I'd love to hear it and chat in the replies.